End behavior tells you what's going on at the ends of your graph. Are they pointing up, down, sideways? We figure out end behavior by looking at our leading coefficient and our degree. The leading coefficient is the number with the x that has the biggest exponent. So in these two examples, my biggest exponent here is 5, so the 2 is my leading coefficient. In the second example, again, my biggest exponent is the 5. Usually it's the first exponent that you see, but not always, so make sure you check all three exponents. So my leading coefficient is this -9. The degree is your biggest exponent. So in both of these, my degree is 5. All right, so how does the leading coefficient and the degree explain anything about our graphs? Let's look at a few examples. You may want to pause the video here and see if you can figure out, look at these examples, can you answer these questions? If the leading coefficient is positive, as in these first three examples, then your graph ends pointing up. The right-hand side points up. On the other hand, if your leading coefficient is negative, as in these other three examples, the graph ends pointing down. The right-hand side is what I'm referring to. Okay, well now, how can I tell the difference between this degree versus this degree? If your degree is even, as in these three graphs, then both ends of your graph point in the same direction. If your degree is odd, as in these three examples here, then the ends of your graph point in opposite directions. I remember this because odd, op, they're kind of similar looking words. Okay, let's actually figure out the end behavior now for a couple examples. What is the end behavior for those first two examples that we looked at? Okay, example A, my biggest exponent is the 5 here. So that means the 2 is my leading coefficient. It is positive 2. So my leading coefficient is positive 2, which means the right-hand side of my graph is going to point up. Positive points up. My degree is 5. That's an odd number, which means they're going to point in opposite directions. So if the right-hand side points up, that means the left-hand side is going to point down. And that is my end behavior for this graph. In the second example, our biggest exponent is here in the middle. So that means this -9 is my leading coefficient. It's negative, which means that my graph is going to end pointing down. The right-hand side will point down. Just like before, my degree is 5. 5 is an odd number, so odd equals opposite. So if I end pointing down, that means opposite direction. It has to start by pointing up. Okay, so what if we have something written in factored form like this? Do we have to multiply it all out to figure out what our leading coefficient and degree are? That would be a nightmare. In this case, there are some shortcuts that we can use. So in factored form, you're going to use the sign of any number that you see in front of the parentheses as the sign of your leading coefficient. So if you don't see any kind of sign there, that means it's implied to be positive. So I will use this -4. My leading coefficient sign is negative. I will use this. That is no sign written, so that means that it's implied to be positive. Same idea. The 2 is written in front of my parentheses. It is implied to be positive. And here, even if there was nothing written in front of your parentheses, it would be implied to be a positive. But here we have a specific negative written. All right, well, what about the degree? The degree is a little bit harder just because you have to add now instead of just look straight forward. So for degree, you're going to add the exponents on the x terms or any parentheses that contain an x. If no exponent is written, you have to remember it's implied to be a 1. So let's do some examples. All right, in this example A, I don't have an x, but I have an x here in this parentheses, so I need to use the 2. and I have an x here in this parentheses, so I implied to have a 1 there. So add your exponents together. 2 plus 1 means that my degree is 3. If I was going to determine this end behavior, my leading coefficient is negative, so the right-hand side points down, and my degree is odd. Remember, odd is opposite, so the left-hand side points up. In this next example, here's an x, and here's an x, and they're parentheses, so I would add those exponents together to get 8. My degree would be 8. 8 is an even number, which means that they're going to point in the same direction. So since my leading coefficient is positive, the right-hand side points up, and since my degree is even, the left-hand side does too. Next example, I have an x here, so remember to put a 1 with it. I have an x in this parentheses, and I have an x in this parentheses. So I have to add all of these together to get 9. My degree is 9, which is an odd number. Remember, odd and opposite. So since my leading coefficient is positive, but my degree is odd. Notice the difference between these two examples. This one, the only difference is this x right here. There's no x there. All right, and in the last example, I have a cubed. There's an x here, so it's implied to have a 1. There's an x here with the squared, and there's an x here, which is implied to have a 1. I need to add all of those together. That is 7. Double checking my math. And that is an odd number, so they will point in opposite directions. So the leading coefficient is negative and opposite.